the way I used to. You're going to see that I'm not very organized with this process, but it works. So you have the equation over there. So the question is, what mass of carbon dioxide is produced? So that is my unknown, okay? My unknown is carbon dioxide. So this is my unknown, okay? And I want to know the mass. It's produced by the complete combustion of 100 grams of hydrocarbon pentane. So the given in this problem is 100 grams of hydrocarbon pentane. So my given is this one, okay? This is my known. And it's 100 grams. Okay, so far we're cool, right? So this is the known, and this is the unknown. Okay, so remember that from both known and unknown, I need the atomic, the molar masses. So I'm going to get the molar mass of the known. Okay, I'm gonna get this atomic molar mass and the molar mass for CO2. I'm going to work on that. So this is 5 times 12, 5 carbons, plus 12 hydrogens, which is equal to 5 times 12 plus 12 times 1. So it's going to give me 60 plus 12 equals 72 grams per mole. So that is the first atomic mass, okay? The second one, the unknown, is atomic mass 1 carbon plus 2 oxygens. So this is 1 times 12 plus 2 times 16. So this is 12 plus 32. In total, this is 44 grams per mole. Okay. Okay. So this is what we have so far. So what I do now is I write my path. Remember, the path is from mass given to moles given to moles unknown to grams or mass unknown, okay? That is my path. Now, I just write the mass given as 100 grams of hydrocarbon pentane, okay? So C5H12. So here, from mass to moles, what am I going to use? What am I going to use?
The molar mass.
The molar mass of the given, right? So the molar mass of the given is this one, 72 grams per mole. So where am I going to put that 72 grams, up or down?
Down.
Down.
72 grams of pentane, that is inside 1 mole of pentane. Okay, so we accomplish this part. So we move on to the next step. That is from moles given to moles unknown. What am I going to use in there?
Molar ratios.
Okay, molar ratios between the given and the unknown. So where am I going to put my moles of pentane, up or down?
Down.
Will be down. How many moles of pentane? Invisible 1. Mole of pentane. And my moles unknown that are CO2. How many moles of CO2? How many moles of CO2 am I going to put above?
5.
Exactly. 5 moles CO2. So now we can cancel these moles with these other moles, okay? So we accomplished the second step. And then I move on to that next step, that is from moles unknown to mass unknown. What am I gonna be using?
The molar mass unknown.
The molar mass unknown, okay? So where am I going to put, the moles of CO2, up or down?
Down.
Down.
1 mole CO2 that has a mass of 44 grams of CO2. I can cancel the moles of CO2 with the moles of CO2, just like I did over there. And the remaining units will be grams of CO2. What is the answer that you get from here?
305.5.
305.5 grams of CO2. Oh, I didn't check, but I'm trusting you.
It's because after the 305 appears a lot of
Oh,
5, so I only
yes,
put 1 5.
to be 56, okay? That would be also correct. But don't worry, we're not going to fight for that. And that's it. You can see the process that I did is a lot faster than I used to do it. Now, I prefer that you are organized, but in this way is faster. So choose the procedure that you want. Now, let's take a look. Do you have a doubt on this exercise? Do you have a doubt on this exercise?
No.
So let's move into the other exercise because I want you to have more explanations just in case you need it. So it says mercury can be isolated from its ore by the reaction. You have the reaction over there. And the good news for you is that it already balanced. Okay, and it's asking you 2 questions, okay? So it says, how many grams of, I'm going to work right now with the first one, okay? So how many grams of mercury are produced from 87.6 grams of mercury sulfide, mercury 2 sulfide? So in my first question, in my first exercise, I'm gonna work with the same equation, but I'm just going to focus on the question that is asking you to do. Gosh, I hate this. Okay. So I have my equation over there and I will focus on this. So the question here is given me 86.7 grams of mercury sulfide. So this is going to be my known, okay? And my unknown is going to be what the question is asking you to find. It says how many grams of mercury. So grams of mercury is going to be your unknown. So this mercury alone is going to be your unknown. Okay, and the given is mercury 2 sulfide that you have over there, 87.6 grams. Now, from this, we need to write the molar mass. What will be the molar mass of mercury sulfide? It's going to be 1 mercury atom plus 1 sulfur. How much is this? So for mercury, I have 200.59, and from sulfur, I think it's 32. 32.007. No, not 007, 07. Okay. This is the molar mass I got. I don't know if this one is the same that you got, but we're not going to fight if yours is a little bit different, okay? If it's accurate, it's okay for me. This is what I got, 232.66 grams per mole. And for mercury, it's going to be the same atomic mass, okay? It's going to be 200, because it's a single element. It's not combined. So it's going to be 200.15. 50 what? 59 or 56? 59.
59.
And then what we do is the conversion process. So we always begin with the given 87.6 grams of HGS times. Okay, remember, we need to put always the, okay, the pen. It's from mass given to moles given, from moles given to moles unknown, and from moles unknown to mass unknown. Okay, that's how I do it. And then I continue with this. So I'm going to be using from mass to moles. I'm going to be using the molar mass. So here I'm going to write the molar mass. That is, where am I going to write the grams? Up or down?
Down.
Okay. Check. Now from moles given to moles unknown, I'll be using what?
Molar radius.
Okay, where am I going to put below? Where am I going to put below?
We are going to use the molar radio and we are going to put below 1 mole of, no, 4 moles of HGS equal 4 moles of mercury. So the second step, check. And then
from moles unknown to mass unknown. What am I going to be using?
Molar mass of the unknown.
So the molar mass of the unknown, where am I going to put the grams? So up or down?
The grams up.
The grams up. 200.59 grams. Of mercury, and below 1 mole of mercury. Okay, so here you can cancel grams with grams, moles with moles, these other moles with these other moles. What is the answer that you get?
I get 75.53 grams.
How much?
75.53.
7, okay, 75.53 grams of mercury. Voila. Okay, how do we multiply this last one? So in your calculator, you're gonna do this. You're gonna put it what you're gonna do in the calculator. So this is going to be 87.6 times 1 times 4 times 200.59. Everything that is in the top multiplies. Then you're going to divide everything that is below. So this is going to be divided by 232.66 divided by 4, que es este de aquí, okay? And divided by 1, que es este de aquí. How much you got?
75.53. Means that doesn't matter if I use look I in the calculator I put it is the grams, then divided by 232 times 4 divided by 4 and then times 200.
No, in the end, it doesn't matter. It doesn't matter because here you are just multiplying or dividing. And remember that in math, in the order of operation, multiplication and division, they are done in the same level. Okay, so
Yes.
here it doesn't matter. But in other kind of exercises, it matters. Is for example, in a parenthesis, you have an addition or a subtraction. Okay, so you have to perform what is in the parenthesis first, and then do the rest. For multiplication and division, doesn't matter if you multiply, divide in the same place. So in my
Means only that I have a question with these numbers that, for example, in the with the Avogadro number that we put the exponent to a power and all that, how we pass the exponents is because in physics yesterday I got a answer like that. I don't know if I have wrong, but how I pass that answer of exponents to a normal answer, or I have to change the mode in my calculator or something because one of my classmates they got the same answer but with 0.00
okay,
and I
so
got it in that.
in your calculator, what you have to do is press mode, okay, several times until you see this. Until you see this. I don't have my calculator here, but it's going to give you something here that I don't remember. Psi and norm. And it's going to give you like a number, 1, 2, or 3. For example, if you have in scientific notation your answer and you want it to be normal, you have to press the number that is below norm. Okay. and then okay or equal.
Okay, Miss, thank you.
Okay, okay. Any doubt on this exercise on part 1? So you see, in the 30 minutes of the class, I am about to do 3 exercises. So if you work fast today, you're gonna be able to make all the homework correct. If you do the long process, you still can do it, but it's going to take longer. Now it's going to look a lot better, that's true, okay? But I also care that you work faster, because in the quiz you need to work faster. Okay, so I'm going to focus on the second question. Says how many grams of calcium sulfide are produced along with 9.25 kilograms of mercury. Now here, be careful in this part, because this mass given here is in kilograms, which means that you need to do a conversion from kilograms to grams. Okay, that is going to be like the step 0 in this exercise. So I'm going to copy and paste the equation, because I don't want to write it again. I'm that kind of lazy. I know I won't be able to make it. A ver si funciona. Bueno, bueno. Bueno, 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 bueno. Okay. So let's focus on this question that says how many grams of calcium sulfide are produced along with 9.25 grams of mercury. I'm just going to copy and paste the question better. I need to work in that part. Remember, this is the question number 2. Like that. Okay, so in this question, it's gonna be relating the 2 substances that I care, okay? So what is the unknown in this question? What is the unknown in this question?
The grams of calcium sulfate.
And the given is
Mercury.
mercury, 9.25 kilograms of mercury. So as I told you, the step 0 is going to be to convert from kilograms to grams. When you do that conversion, this is going to be 9,250 grams of mercury. And now this is going to be your given, okay? Is that what you got in the conversion? It should be, okay? It's just multiplying times 1,000. So now I'm going to put the information, the unknown, that is calcium sulfide, and I need to know this mass, okay? And the given is mercury, 9,250 grams. That is the given, okay? Now we write the molar masses. The molar mass of mercury, I got it from the step before, or from the periodic table directly, and is 200.59 grams over mole. And calcium sulfide is 1 calcium plus 1 sulfur. This is going to give you, I forgot what the calcium mass is. 40. So it is 1 times 40 plus 1 times 32. So this is going to give me 72 grams per mole. I rounded it. Okay, I rounded it. It's okay. You can use it like that. Now I do my path, and I know that this is from mass given to moles given, from moles given to moles unknown, and from moles unknown to mass unknown. Okay, I do it like that because it's faster. So I begin with my information, with my given. So it is 9,250 grams of mercury. Now, from mass given to moles given, I need to use molar mass. So where am I going to put the moles, up or down?
The moles up.
1 mole of Hg goes in the top, while the mass is below. Okay. From moles given to moles unknown, I'm going to be using the molar ratios. What's the molar ratio between the two substances? Let's see. Paola, what is the molar ratio between the two substances?
Sorry, Miss, I don't hear you well.
What is the
Can you-
molar ratio between the two substances?
72 grams of mole.
That's the molar mass. I mean the molar ratio. Remember that from moles to moles, what you have is molar ratio. And we are related mercury and calcium sulfide. So the molar ratio is going to have 4 and 3. That's the ratio. Where are you going to put mercury, up or down?
Down.
4 mole
Mercury
of
down.
mercury down. Therefore, calcium sulfide is going to be up. And thank you. And in the last step, where you relate the moles unknown and the mass unknown, you're going to be using molar mass of the unknown. So how are you going to put the molar mass of the unknown in this parenthesis? Fernando.
1 mole of calcium sulfur
Where?
up, and sorry, 70, yeah, 3 moles of calcium sulfide.
No, remember the
Wait,
molar mass
yeah,
is
yeah, that one.
for 1 mole only, okay?
Yeah.
So the molar mass is 1 mole of calcium sulfide over the mass, 72 grams, or 72 grams divided by 1 mole. So how are you going to write it? Where are you going to write the moles, up or down? If you
The
want
moles down and the grams up.
1 mole CAS and the grams up. And now you can see that you can cancel everything. Not everything, I mean everything you don't need. Like here and here, or here and here, and even here with this one. What is the answer that you get?
Miss, I got 2,490.15.
That's what I got too. 2,490.15. And these are grams of calcium sulfide. Bueno, no se mira, but I did it. Why? Why is this happening to me? Yeah, now it works. So as you can see, yeah, the procedure can be long, but if you get used to it, you can do it even faster. So my recommendation is that you memorize the path. If you memorize the path and you know how to relate mass in moles with molar mass and moles in moles with molar ratios, you're gonna be okay. Do you have a doubt in any step of this exercise, Nelson?
Only question, the path of mass given, most unknown, mass unknown, that will not change in any exercise.
In this one,
For
from
grams per gram.
grams to grams is gonna be the same. So the path, if you memorize it, you'll be okay. Any other doubt? Bueno, good luck with your homework.